Hi, welcome back to Understanding Basic ECG series. Our second lecture is about the ECG paper and heart rate calculation. The ECG grid is formed of two types of boxes, small boxes and large boxes. Each small box is 1 millimeter in width and 1 millimeter in height. The large boxes are 5 small boxes in width and 5 small boxes in height. If we look at the duration of the small box duration is 0.04 seconds. So the large box is 0.04 by 5, which would be 0.2 seconds. This means that we need 5 large squares, 1, 2, 3, 4, 5, to have 1 full second. Another important issue is to look at the standard amplitude setting or the calibration box, in which the standard that 1 millivolt will give deflection for 10 millimeters, which means 2 large big squares. This is a standard in all the ECGs. Half millivolt will give deflection only for 5 millimeter height, which is 1 large box. But in all ECGs, you will find that the standard is 1 millivolt and gives deflection for 10 millimeters. You can use the lower half millivolt in case if you have very high amplitude waves and you need to restore them within the ECG grid. But this is not the standard. Therefore, the ECG operate on a mathematical grid. The horizontal axis reflects the duration, and as the standard universal paper speed is 25 millimeters per second, this will be helpful for us to know the duration of the waves. And the vertical axis reflects the amplitude, which measures the electrical force of the heart signal. And as we agreed that 1 millivolt will give 10 millimeter deflection. So let's make some calculations. As we said, the paper speed standard ECGs are recorded at 25 millimeters per second. We know that each small square is 1 millimeter width. This means that if we divide 1 millimeter by the speed of the ECG paper, which is 25, will give us that the speed or the duration of the small square is 0.04. And we know that each large box or large square has 5 small boxes. So if we multiply by 5, this means that 5 by 0.04 means the duration of the large square or large box is 0.2 seconds. And consequently, 5 large squares equal 1 second, and 15 large squares equals 3 seconds. And usually in the ECG paper, you will find a mark every 15 large squares marking 3 seconds. And if 1 second equals 5 large squares, this means that 60 seconds will, or 1 minute, equals 300 large squares. And we know that each large square has 5 small squares. So 1 minute equals 300 large squares or 1500 small squares. This is important in calculation of the heart rate. So this takes us to how can we use the ECG to calculate heart rate. As I said, every 15 large squares or 3 seconds, there is a mark on the ECG paper. So the first method, if you get 6 seconds on the ECG paper, mark them, and then calculate, which is 30 large squares, and then count the number of R waves. 1, 2, 3, 4, 5, 6, 7, 8, 9. And they are 6 seconds. We need in 1 minute, so multiply by 10. So multiply the number of R waves by 10, it will give you 90 beats per minute. This is the heart rate. Actually, this is ideal for irregular rhythm or as a rapid bedside estimation. In the second method, allocate R wave which hitting a bold large box line, and then count the numbers of large boxes until the next R wave, which we call RR interval. And then we know that 1 minute equals 300 large squares. So divide 300 by the number of large boxes. This will give you the heart rate. So if, for example, if the distance between the two R waves is 1 square, so it will give you heart rate of 300. 300 by 1 is 1. 2, 150. 3, 100. 4, 75. 5, 60, and so on. Another method, which is similar by calculating the R interval, but sometimes you don't find the R waves are hitting large boxes, all of them. In this case, you need to use the small squares to get accurate calculation of the heart rate. In this case, you will do the same. So you will count the exact number of boxes, but here small boxes between the two consecutive R waves, and you will divide 1500 because we know that 1500 small squares equals 1 minute. So we'll divide 1500. Here in this case, the R16 small squares will give you heart rate of 94 beats per minute. So it is similar to the previous one, but in this one you use 1500 because you use the small squares, and the previous one you used 300 because you used the large squares. So this method is reserved for exact precision calculation in regular rhythm. I hope this was helpful to understand the ECG paper and ECG calibration, and to understand how we calculate the heart rate. Next lecture, we'll talk about ECG leads and ECG waves. Thank you.